This video is a production of the College of Arts and Sciences at Eastern Kentucky University and has been made possible through an EPSCoR grant from the National Science Foundation.
Everybody has probably hit their head on something and not thought about it. You know, you wake up in the morning, you're going and you grab a towel from a shower bar and you hit your head and you don't really think about it. You just think, oh, my head hurts, and that's it. But there could be something really, really wrong. I'm Tanea Reed. I am in the Department of Chemistry and I am Assistant Professor of Biochemistry. What I look at is traumatic brain injury. I think the main issue with our research is that it's relative to everybody. Mostly dealing with older populations and young children. Traumatic brain injury is a huge deal. There's no cure for traumatic brain injury. If you hit your head really hard, go to the ER. They're just going to treat the symptoms, but there's nothing else they can do. What I look at is specifically drugs you can give somebody after they have an injury to prevent any further brain damage from occurring. The number of traumatic brain injuries that occur a year are about 10 million worldwide and roughly 2 million in the United States. It's hard to figure out the statistics because a lot of people don't report a brain injury or they don't go to the hospital. Those things can really turn to be very problematic. Some people can get memory loss, balance issues, and that can be a bit of a problem. So if there was a drug to try to prevent any further damage from happening, that could really impact people's lives. So we do use animals in our research, and they go through what's called a controlled cortical impact. And this is where their brain is injured. And then after the injury is given, we do give them an injectable treatment. What we hope it will do is it'll help to produce more antioxidants in the brain. So more antioxidants mean less brain damage overall. We have treated the animals, they're up and they're active and it's like nothing has happened. Generally about 10 to 30 minutes after the treatment has occurred. And we do lots of different tests to figure out how much injury the animal actually has sustained due to the controlled cortical impact, and then giving the treatment if this treatment has actually helped to prevent further injury. So with sports-related injuries, there's a big push right now for concussions and trying to make better football helmets, baseball helmets, because concussions are a very big issue. You get hit in the head with a baseball, you get hit in the head with a football, you just get knocked unconscious. So if there was some type of medication they could have on the sidelines, that could change the whole realm of professional sports. So it's not just more of science being done in a lab for things that you'll never think about or don't really have any barrier to you, but it's really something that you've probably known somebody to have a brain issue, or it could be relative to you.